So hey everyone, and welcome to another live stream. So in my previous session I discussed 3 interview questions regarding YouTube system design for freshers and for 3 years of experience. Now let's take that a step further by asking Claude, uh, give 3 interview questions uh, regarding YouTube system design for 5 years of experience, and along with answer, because definitely I don't know the answer to those questions that this uh, Claude code will generate. So let me have the solution as well along with solution. So here are 3 system design questions. Design YouTube metadata database layer. Okay, so this is very important, and here metadata refers to a video title, like count, things like that. So YouTube has 2.8 billion videos and serves user worldwide with very low latency. So design the database architecture. So the capacity we're looking at is something 500 hours upload per minute. Writes are relatively low volume versus read. Vastly outnumbers write likely. So in the step one, it's saying that even though we have a lot of videos on YouTube, mostly those are read heavy, because you upload a video once and then you have 1 million people watching it. So read to write ratio is 100 is to 1. So this is read heavy, skew drives most design decisions. So since it's very focused on read heavy, we'll be keeping in mind that everything that we do is optimized for reading and not writing. Now we have the sharding strategy. Whenever designing a database comes, just mention sharding. You have to shard a database then for horizontal scaling. So shard the primary metadata store, example a distributed SQL, NoSQL, um, and it is going to be hashed by video ID. Avoid sharding by channel ID. A single viral channel would concentrate all its video traffic. Use a separate index or lookup service. Multi-regional architecture. New video uploaded description happen in home region close to the uploader, then asynchronously replicate to the other region. Metadata reads are served from the nearest region replica, acceptable to be eventually consistent, and use a multi-leader or leader per region replication. Hot data caching, key trade-offs, blah blah blah. So design the recommended videos or home feeds section. So this is question 2. Let's focus on question 1. So this is going to be uh, 5 years of experience. So the first question is, which can handle billions of videos and users globally. So let me recap the solution so that it's easier for me to remember. You can summarize however you find easy, so that the solution of this question sticks to your mind. So YouTube has 2.5 and users worldwide. So let's say step 1, um, since YouTube is read heavy, all our optimizations are centered around reading. Fine. Okay, so this step 2 is sharding our database. shard the primary metadata store by video ID. This evenly distribute videos regular regardless of popularity, avoiding shards from any single popular channel. So if you don't know what sharding is, it's a system design concept in which you try to horizontally scale a database infrastructure. And if you're vertically scaling a database, then you will add more DB instance to your application. But in case of sharding, you break it into different chunks. So now that you have various chunks, how do you decide which data should go into which shard? I shouldn't say shard, but chunks. So I'll open my uh, Excel draw. This is from my previous so let's just say this is my primary database. Okay, primary DB. Now what I'll do, I will use sharding and create into shard S1, shard S2. Let me copy these two. So this is S1, S2, S3, and then we have the S4. So how do you shard? In case of sharding, you have to define the shard key. In YouTube, we pick the video ID as the shard key. And why video ID? Because regardless of popularity, because if you're using channels, so some channel can be popular, so every popular channel will be going to one shard, so it creates a problem. Now we have multi-regional architecture. So we have the end user. So this is a different question. So let's just say I have a user. Is there a okay, let's just say this is the user, and this is present in region R1. So now what we need to do, so the metadata is kept in the a server which is physically closer to the user. So this is the server where the raw footage transcoding everything is done, and then we have different regions which have their own CDN, things like that. Now you want to replicate this slowly into different regions so that users viewing from other uh, different part of the world can watch the video with very less latency. And then you slowly replicate the data into the servers which are in different regions. So this is region R2, this is region R3, and this is another server. And what happens, things get slowly replicate to other region. and I'll say video plus metadata, video plus metadata, and slowly replicate to other region. So use a multi-leader or leader per region replication model. I don't know what this is. What is multi-region? View count specially use the right batching pattern discussed earlier. Okay, still hot data caching layer. Popular videos metadata sits in distributed cache in front of the DB. Okay, and then step 3, uh, trending slash popular video metadata sits in cache before DB to avoid, you know, hitting the DB every time. Key trade-off to discuss: strong consistency. So the database for YouTube prefers eventual consistency, which means the data is not immediately reflected or updated, but rather happens in batches in some intervals. Choosing hashed video ID, sharding sacrificability. Okay, okay. Now the second question is design a recommendation system. How would you design the system that powers YouTube homepage recommendation for 1 billion users updated in real? Split into offline and online layer. These two layers architecture is the core insight expected at this level. Wait, what? Split into offline and online. Offline is called batch, online is called real time. This two-layer architecture is the core insight expected at this level. Offline or batch layer, candidate generation plus heavy ML. Batch pipeline, Spark jobs on top of data lakes and historical watch history. Trains, update embedding models. Users and videos are represented as vector in the same. Okay, produce a candidate set per user, top 500 likely relevant to them. When a user loads a homepage, the request hits the ranking, pulls the pre-computed candidate set for the user. Okay, trending slash fresh content injection, a separate fast pipeline. And then there's a feedback loop. Keep trade-offs. So to summarize this solution, uh, we have two layers to this problem. I'll say recommendation system, and here we have two layers. One is offline, happens in the background, and then we have the online one, and this is heavy on ML, and there are various pipelines heavy on ML, vector DB, and from here, and then we have embedding models. So if you don't know what vector database is, let's just say that you have a graph okay, and then there's a line pointing from point A to point B. So you want to find all other lines which are very close to that, so which means they are very similar to each other. Now when a user loads up, so there, this is, that's fine, okay, so this is the ML part. I'm not going to go too deep into it because again ML is a completely separate branch. So when a user loads the homepage, the request hits ranking servers, pulls the pre-computed candidate set for that user. Pre-computed, so when was it pre-computed? It didn't mention that. Re-ranks those candidate using real-time signal. Oh, okay, based on your day, device, current, trending, things like that. Not the full heavy training model, scores, order candidates. So I think this is very fast and this is slow. So I'll say heavy on ML, this is fast, based on user activity. Uh, but still, does this even use a vector database? Ranks the candidate using real-time signal. Uh, so based on, you know, day, device, uh, watch time, things like that. And probably this all happens on historical data such as a watch history. Now there's a feedback loop. So again, they will recommend this and the user will interact with the result generated by the offline and online data, and based on that again they will retrain them. Okay, and from here a feedback loop. So why not compute recommendation full in real time? Because it's too expensive. Okay, staleness, uh, exploration versus pure, most क्या है pure, most similar to past behavior. Cold start problem, new user, new video with no historical data. Fine. I think these points are worth keeping in mind. The trade-offs with um, computing or generating data in real time is expensive. Then we have new users without any data, so they are recommended videos based on popularity and trending. You have to keep staleness in the mind. You don't want to show the same videos over and over again. And then exploration versus exploitation. Sometimes recommend new videos, but what does exploitation means? More similar to past behavior, recommend filter buggers, real system inject some randomness, new interest and avoid overfitting to history. Yeah, So okay, thank you guys so much for watching, and I'll see you guys in my next live stream. GGWP.